record. We can get going here. I think this will be pretty short, even though we're covering 2 chapters, guys. Any questions on any of the labs that we've had so far? Everyone able to get through Ether channel and HSRP okay? All right, I will take that as everyone is doing well. If not, just reach out to me and let me know. I haven't heard from anybody, so I'm assuming everything is great. So we're going to introduce some dynamic routing today, and we're going to be covering chapter 5 and 6. Theoretically, we could also include chapter 7 today because it both covers in Eigrp. However, that would give you guys a pretty big workload. Like you'd have like 4 labs to do. I try to kind of even things out with just about 2 labs per week. So that's kind of why we're breaking things up this way. Chapter 5, you'll notice there is no labs. No labs at all for chapter 5. It's all theoretical. I think there's just one slide I'm going to show you, and that's about it. Then we'll jump right into Eigrp. It'll give you an introduction to Eigrp and how to set it up. And then next week, when we cover chapter 7, it's how to kind of tweak some of the parameters for Eigrp. Okay, and then we'll finish off with OSPF, which is another dynamic routing protocol, and that's the next 3 chapters. And I think I usually cover 8 and 9, but I might just throw in 10 as well, just to kind of finish it all off. And then the week after that, we'll start introducing the final and everything else and give you guys a few weeks to practice that. So let's jump right into it. So dynamic routing protocols. So far, the only routing protocol that you guys have learned in Cisco 2 was RIP. And RIP was okay. It is not great. It is dumb, though. If you look at this video here, the RIP strictly, the only parameters that RIP uses is the number of hops, the number of routers that it has to go through. It does not take into consideration bandwidth, congestion, timing, down interfaces or lines or anything like that. So with PC1 wants to send something to PC2, it will take this 56K route, even though that's dial-up modem route, going from router 1 to router 2, and it will go that way because that is the shortest path in its eye. It's only 2 hops, right? Instead of 1, 2, 3 hops going out to router 3. RIP will see that as wasteful. But, and maybe that's not too bad if you're sending a text file or something that's pretty small, going through this dial-up may not interact anything. But if you're definitely streaming, sending video, sending some other large data, you definitely want to go through the faster T1 lines. Let's see if I can make this a little bigger. Hopefully you guys can see it okay. So Eigrp or OSPF takes bandwidth into account as well as other information as well. So it will notice that these T1 lines are a lot faster. And so even though this is a shorter path, so sending something, if you have OSPF or Eigrp on, it will take the fastest route, which is router 1 to 3 to 2 to router 2. So they're a little bit smarter based upon bandwidth and other parameters, right? So let's get into what Eigrp is. That's chapter 5, guys. See, we're all done. So what Eigrp is, it is a Cisco proprietary protocol, which means it only works on Cisco devices, right? Let's see if we have something here. Yeah. So it only works on Cisco devices. It's when we get to OSPF, that is a more open protocol, which works on other devices that are not Cisco devices. And I actually prefer OSPF. But anyway, we'll learn both. Since this is a Cisco class, we'll learn about Eigrp. So you have to have all Cisco devices for EIGRP to work, right? There are different versions of EIGRP, one for IPv4 and one for IPv6. We'll just be focusing on the IPv4 for now. EIGRP uses a proprietary protocol to communicate called RTP, Reliable Transport Protocol. Instead of using TCP, it uses RDP. RDP, again, is proprietary. It's only for Cisco devices. It works similar to TCP, but is only designed for EIGRP routing to send messages back and forth. So what type of messages does this send? And what type of features does EIGRP use? Well, let's talk about some of the features, and then we'll get to some of the features. Let's see here. One thing that EIGRP can do is authenticate. You can set up passwords between routers so that only routers that can authenticate by setting up a username and a password on router 1, router 2, and router 3, they all have to have the same username and password, and then EIGRP can be authenticated. If you introduce a new router onto your network and it does not have that username and password, it is not encrypted, and it will not authenticate, and will not pass EIGRP traffic through there. So one feature of EIGRP. Let me show you some of the traffic that goes through. 2.1. Oh, here we go. So we talked about how EIGRP uses something called RTP packets, or segments actually, instead of TCP. Well, it does. And what it does is it sends out different types of communications through RTP to discover the bandwidth, to discover if another router is running EIGRP, to get its routing tables and its information from the other router. And so they're constantly sending these communications back and forth. The way they send these communications back and forth is using RDP, which is reliable delivery, right? So here are some of the different types of communications that EIGRP send out. There's a hello that goes out, I forget, it's like every 30 seconds or something like that. And it is just to discover other routers that have EIGRP so that it can always keep in communication. Oh, hey, you have EIGRP? Great. I just sent you a hello packet. It responds back, say, yep, I have EIGRP. Good, we're buddies then. We can communicate with each other and we're good. They also send update packages as well. And this is where you get the majority of the EIGRP information between the different routers. It will actually send the routing networking tables and topology tables between the routers. So if one router has a network on the back side of it, it sends that network information over to the other routers which are in its same group. And that comes through the updates. This doesn't come as often as the hello packets. It comes a little less frequent, I think about every minute or so, to kind of cut down on bandwidth because it is a lot of information, or can be a lot of information. Some of these are reply backs and queries that happen with the hello and the update packet. And then there's an acknowledgement that it's received it. That's part of the reliable part of it, right? Just like TCP sends out a segment, it waits for a response, make sure that it got delivered. If it didn't get delivered, it will send it out again, right? If it did get delivered and was received, it will send back an acknowledgement and say, hey, I got it, so I am good, right? It does take up extra bandwidth, but it's very reliable. It makes sure that all the routers have all the necessary information they need to make the best routing decisions possible. So just be aware of some of those. You will get some questions on those on the test. All right. Got to talk about one other thing, and then these are the hello packets. We don't need to talk about that. Now, one new concept that we're going to be talking about here is called autonomous systems, or ASs for short. EIGRP only works within what's called autonomous systems. And what an autonomous system is, it's a group of routers that have EIGRP. So what we're going to figure out here is, so as you can see, there's one large internet provider, ISP1, and they have an AS, autonomous system, with this number right here, right? And so this is our companies, that there's company A and company B that are on that internet provider. Company A has, company C, D, there's all three different companies. So each company will need to have their own group of autonomous systems for their own EIGRP group. So there's a number that you specify for your autonomous system, so to identify yourself from all the other EIGR groups. Okay. And so we'll designate, and I'll point out that number when I actually show you on the router itself. So we have to take into account that these routers are grouped together. They need to be part of a group of ERG. It's the group in which they share information. And so it's just called autonomous systems. You assign it a number. The command is actually right here, but I'll show you in the command line. It's router EIGRP, and then you give it a number. The number is kind of arbitrary, the AS number. You define what that is. Within your own company or organization, you may have different ASs. And so it just depends how you want to organize your network. So let me get to the command line here and to our lab, and I'll demonstrate how to set up EIGRP. It's not too difficult. It's very similar to RIP, but we'll have a little bit more functionality than we will with RIP. All right. Make sure you guys can see that there. So here is our lab, the lab that you have for this week. This is the configuration setting. Now, on my devices here, I actually only have 2 routers. I don't have 3 routers set up, but the configuration is the same on all the routers. You just repeat the steps on each of the router. So what I have set up is this connection between router 1 and router 2. And so we're going to set up EIGRP between router 1 and router 2, but you set it up exactly the same between router 2 and router 3, and between router 1 and router 3. Okay, so I have already set up all of the IP addresses for each of the interfaces for each of these. So let's go ahead and set this up. It won't take very long at all. Okay, let me go to router 1 first. Left off on router 2. So you can see here, I just set up the IP addresses. Here's my serial connection that connects to router 2, 10.1.1.1. You can see that it's up. And here's my connection to my end device. Right here to PCA. Right? So I've set up the serial interface, and I set up the gigabit interface to PCA. We'll go to router 2, and I'll just kind of show you what we have set up here. So you can see that the serial interface is on the same network there. There's our 10.1.1 network that they're connected to each other. I should be able to ping router 1 from router 2. Yep. So that serial connection here is set up, you want to make sure that that is intact, right? And then these route. Now, at this moment, since we haven't set up a routing protocol, PCA will not be able to ping PCB because we haven't set up RIP, or we haven't set up EIGRP, we haven't set up any type of routing protocol. Even every router needs to have a routing protocol of some kind if it's going to go from one router to another. So we have to set that up. So in your lab, it may or may not ask you, can you ping? At this moment in time, we cannot. So let's go ahead and set up EIGRP. Let me actually just get on router 1. We'll kind of do this in order here. So you need to go into global configuration mode. We need to go into the router configuration, similar like we do with RIP, but it's router EIGRP. And this is where we assign it the AS number, that autonomous system. Remember the autonomous system I talked about? That's this number here that we have to give it. And right here, we have to give it a special number. The number is arbitrary. It can be any number you want. However, you have to use that same number on all routers. So in your lab, I believe it gives it AS number 10. And that's pretty common. Usually you do 10, 20, 30, 40, something like that. And so that's what that 10 is for. It's the AS number that we gave. And like I said, you can use any number you want. I think up to 65,000 something. You can't use like 1,000,000 as the number. But anyway, now what we're going to do, similar to RIP, is we are going to, so we're in router 1, we are going to tell EIGRP the network that we have connected on each side, right? So I'm connected to PCA, so I'm going to describe this network, and PCA, let's see if we get back here. Router 2, router 1. Remember, PCA is on this network, the 192.168. And then we're on the 10.1.1 network between the two routers. Now, if I had my third router, we'd also want to identify this network right here between router 1 and router 3. So we're going to identify all 3 routes, just very similar to what you do with RIP, where you actually type network, and then you give it the network IP address, .0, right? And then you do use the wildcard mask that we've used before. So that's the 10 network. That's this one right here between router 1 and 2. Then I'm going to do the network for the PC and device. Whoops. There we go. And if I had my third router set up, I would put in the network for this one, which would be, let's see, we have it here, which would be this, yeah, 10.3.3.1, right? But I don't have that connected in my example. And then we're good. Then you go to your next router and you do the same thing. So now in router 2, I'm going to provide the network for PCB, and I'm going to again apply this one. Even though we did it for router 1, we need to do it for router 2, that it's connected to this network. Start up here, go in global configuration mode. We do need to go into the router, EIGRP, and then it has to be the same AS number, 10. Since we use 10 in router 1, we have to use 10 in router 2. Going to provide the network. Let's see, and then what was the network for PCB? 2. Oops. There we go. That's it. That's how you set up EIGRP. Now, how do we verify this information? Well, let's see. I'm going to go back to router 1. Now that we've set this up, PCA should be able to ping PCB. Let's verify some things here. IP route. So here's our routing table. We should be able to see a dynamic routing. If you look up here in the code, D stands for EIGRP. So we should have EIGRP. So here's D down here. This shows that we are through the dynamic routing, we have 192.168.2.0. Well, how did router 1 is not connected to this network, right? The 2, let's see, is right here. That's PCB. Is that 2 network, right? I'm on router 1. Router 1 should have no idea what's behind router 2, right? But with EIGRP turned on, router 1 now knows that if it needs to send something to 192.168.2. whatever, that it needs to send it, that router 2 has it back behind there. That information was provided by the RTP packet or segment with an update where it updated and sent it to router 1 with one of its updates. So we can see that right there. This might want to be a screenshot on your lab, right? This is called the priority that's given. We'll talk about that later, or the administrative distance. That's what that 90 is. This is an algorithm number used by EIGRP to figure out the best path. Talk about that later. All right, what else can we do? We can also do show IP EIGRP neighbors. There we go. This doesn't help too much because I only have one router connected. But look at here. You can see that we're in AS number 10, right? We're showing that through the serial interface. We're on that network. If you were connected to router 3 as well, if I had 2 routers there, you would see 2 entries here, one for each router. I'd be able to see this connection, I'd be able to see this connection, and I'd be able to see this connection here. So you should actually see 3 when you run this command, this neighbors command with this, if you do the lab correctly. All right, what else can we look at? Let's look at show interface serial .0. Let's see what this shows us. One thing this shows us is our bandwidth, which in the next chapter we'll learn how to change. Let's see, what else does it have? Some more reliability, keep alive. Oh, I didn't do it. That's why. All right. Yeah. Oh, that just shows the bandwidth. Okay. That's all I wanted to show. Yeah, what's the bandwidth there? What else do we have? We have the interface, show interface. Let's see. Oh, that's what I just did. Okay. That's all. This kind of preps you for next week where we'll end up changing the bandwidth and some other perspectives there. And guys, that's pretty much it. That's EIGRP in a nutshell. That's it. Pretty straightforward. Want to make sure that everything pings. Everything should ping in this lab. You should be able to see the routes and the networks from everywhere around because all three routers should share their information. So router 1 will eventually be able to see PCC, PCB, and everything else, because router 3 will send that information and router 2 will send that information.